start and kill it. That looks a lot better. Is that looking quite visible?
Yep.
Right. Good evening. My name's Jacob. Just a little bit about me. I'm living in Wellington, obviously. I'm married to my wife, who's in mine. And we have one cat who's not in mine. So I've done a fair amount of things in the software industry. I've been in SCADA engineering. I've been in embedded systems development, real-time systems, some 2D graphics, a fair amount of time in the telecommunications industry, and a little bit of agri-tech as well. So, tonight, I'll sort of walk through the things that I'm going to be talking about. Obviously, it's talking about building your own modular synthesizer in Golang. I was fortunate enough to attend GoCon in San Diego in July, and originally this talk was a lightning talk, so I'm going to basically revisit that format in slightly longer form, and then dig into a little deeper just about how the software itself is put together and have some code examples. So, to get started, and a little bit of background, I work software development as a day job, but I have a home project as well, which is music software and creating synthesizers and that sort of thing. And I've been doing this for a very, very long time. And some of the software that I've written in the past includes this piece of software, which is called Carbon Looper, which is a MIDI sequencer and looping sampling application. As you can see from that screenshot, it's quite dated. The source base was originally written in C and C++. It sort of got to the end of what I could do with it, and I wanted to start over basically. So, after a fair bit of scoping around and just having some of the kind of technology requirements that I was seeking in like a good platform to re-implement that software, I sort of came to these aims. One is that I want this to be quite a very social project that I can actually build in such a way that I can actually just share it on the internet, put it in a web browser and say, people have a look at this link and have a play with the software. I want a technology refresh to get rid of the old legacy code, and I want something that's very affordable. So you may be aware that Golang has a JavaScript transpiler, which will produce JavaScript out of the compiler, which you can then run directly in a web browser, as well as running Golang code natively. And it's a home project, so it's unconstrained by time and deadlines, which is why I've spent years and years working on it and make little increments. So my long-term ambition for what I'm trying to build here is something like a piece of software called Reactor, which is a modular synthesizer environment, a DSP workspace playground almost. So you can just create all these little modules which do various things and wire them up in a graph, and then have that all evaluated, and you play that instrument that you've built out of the most primitive things. So the reasons that I was very attracted to Golang as an implementation language for this refresh, and I did look at quite a few platforms, is primarily because it's got a lot of compile targets. So I can actually build the software in two modes. One, I can run it as native code and build it on as a native application for some of the operating systems that being Windows and Linux at this point. But I can also transpile the JavaScript and run it directly, the entire application directly in the web browser. So that's quite flexible. On the horizon, there are a few other compile targets out there as well. So there's quite a bit of effort in the Golang compiler roadmap at the moment for the WebAssembly target, which is basically an intermediary assembly language for running applications on web browsers, which is just a lot more direct than the JavaScript option, but it's a little early at this point. Progress is coming along there, but it will be another potential compile target that I can aim at to again run the software in a web browser. So now After that evaluation, I've decided on the implementation language of how I want to write the thing, and I've got a vague idea of what I'm trying to build. Here is my minimum viable synthesizer. I refer to this diagram a lot because it's a very good reference point for just the absolute minimum building blocks that you need to produce something which can make a musical sound. Something that sounds like a musical instrument, if it's not very interesting. So just to explain those blocks, the most primitive parts you have is an oscillator, which produces a repeating tone at a specified frequency. An envelope generator, which basically contours the sounds. So if you think of most instruments like a piano key, you hit it rapidly rises to its maximum volume and it slowly falls off. The envelope generator generates that contour. And the final part is a very simple component called a gain, which just basically multiplies those signals together and gives you the output. So, at this point I've got a little bit of a dilemma, which is that I've got this portable platform that I can build with JavaScript. I can also compile it to a native app, but I somehow need a user interface that I can share between the two of them. And that's kind of a challenge. And it needs to work on all those supported targets, so at least Windows, Linux, and web. So some of the options that I looked into for doing this were, for example, just not having a user interface at all for that native target, which might actually be viable if you're sort of playing or performing with it. You might not actually need a user interface. It's not that now I really want a user interface anyway. I could have perhaps done a conventional kind of REST API and actually built the user interface completely separate from the project, and I decided that was just going to be too much work and too high maintenance. And I'm also looked at supporting some low-level graphics APIs like SDL and HTML, Canvas, and again, just too much implementation work. And because I want this thing to be targeting a web browser as the primary experience, that seemed like the natural way to write the graphics. So then I came up with a bit of a crazy idea, which is stream the DOM. So how hard could that be? So I actually generate my user interface on the server, and I send UI patches over a WebSocket and user events back down the other side, which gives me a completely abstract way of generating HTML SVG content on the server and then just running it in the client web browser. Just for explanation on some of the diagrams that I put in these presentations, I decided a while back that in terms of graphic and charting tools, that if the diagram could not be expressed in ASCII text art, it was too complicated. So all my diagrams are in ASCII text art. As a bonus, if you put these dots down the side of the page, it will force the Go present tool to stretch the content to the size of the page, and it will also look like it came out of a dot matrix comes up. So, having talked about it for a while, let's actually have a little bit of a look at it. So just to, let's see. So it's not going to happen, that's all right. Right, so back to that minimum viable synthesizer graph. Now we've got those parts here in actually visible form, oscillator here, envelope generator, and gain. I have an external keyboard which is connected to our app, and we start replacing that, we can actually hear the output. Only one note at a time now because it is a monophonic instrument at this point. But I can try like adjusting a few parameters like this. Change the wave shape. Right. And you can see those components can actually be quite visual. So once I started putting animations into this thing, I'm never going to take them out again. Now that you can have a component which has a little scope on it, and the connectors will light up with the signal strength that's going through them. It just made the project a lot more interesting to work on and to demonstrate. So just to explain a little bit more about what's going on here in terms of how that user interface is presented, and I'm really tempting the demo goals at this point. If I open up a second window, you see that's right. So you see those still just follow along. So what's happening there is that the web browser has opened the WebSocket back to the local connection, and it's just basically streaming those patches of mouse clicks and events going in one direction and DOM patches going in the other. So that's just a really nice, quick way of getting a general user interface into a Go application without being bound to a particular operating system. We'll dig a little bit into the code now, and I won't want to get too involved or put too many people to sleep. But the way that we sort of go about building up those user interface components and demonstrating them, basically, if your component implements this render method, you can return what I'm calling a bed on elements, and that element is basically just a set of HTML or SVG tags that will describe what it looks like and then be pushed over that WebSocket connection in the end. So you can see this one here is a tag placeholder. One of the things I can put on those elements is event handlers as well. So those will be the handle on the server, but they register a hook on the browser that will capture the event and send it down the WebSocket and events like that.
Does that mean that you've got a whole lot of requests coming back the other way from the browser to get SVG resources to show?
Yeah. So the basic flow of control is that generally speaking, a user event will trigger a DOM update, generally speaking. There's one exception to that, which is the server initiated. So that's getting a lot more present now, where we've got this kind of view with all the animations. That, before the animations, the only thing that would actually make this update was pressing these keys. That's an event being triggered on the server side, which is then pushing to the browser. And there is a synchronization question around that, which is actually quite convenient to handle with simple musings. So, it's very much one event, one response, and if it gets any more complicated than that, it's just going to get out of sync. So I synchronize that with the musings. Some limitations of this whole user interface approach. That event handling is quite limited. It's very much one event captured into the browser, sent down the WebSocket, and expecting one user interface update. A lot of the techniques that you use in JavaScript event handling, such as event bubbling, where you might have multiple target objects that could have seen the event, and you said, I saw it, but I don't want to handle it, so I'll pass it up to the next one. But all of those techniques will help. So that means that some of your user interface techniques to get that layer and to get a little bit more creative. There are ways around it.
When you say SVG update, the entire SVG image is traveling over the WebSocket from the server back to the browser.
A patch indicating the changes from the target state of the DOM. So there's on the server, it's like similar to React, if you've seen that. Basically, you do an initial write, which updates the entire state. You do then a state update, which will then produce a patch, which is just an instruction list of the differences between the two. So it's keeping minimal in that way. So it's not quite the entire image, every response, it's just the changes.
That's cool.
We could even see them. So open up a console. There's actually a very rapid succession of patches going down there. But if I dig into one of those, looks like I think my CPU is running out of CPU. So there you can see there's a path, and it's just it's basically just the index of the children it needs to go down to find the target element, and then an attribute to update. So in this case, this one's, you might be able to see that colour is changing on the connector rapidly. Yeah. So that's just basically saying, that target object needs that attribute updated to that value. But each one of those patches, there's only a couple of them in them. So yeah, it's just serving purposes.
So it's getting into the SVG structure itself.
The target DOM structure on the browser, yeah. Yeah, but the server actually maintains its own copy of what it expects it to be. So we've found a very tight network connection where you're absolutely confident that you know what the target state of the DOM is. That won't work. But this is how React works as well. Alright, so I should talk about JavaScript. So everything we've been talking about so far has been an example where I'm running the application in Go as a native compile target and then passing the user interface over a WebSocket. I've got another mode of execution where I can build the entire application into a standalone JavaScript application and run that. So yeah. No, here we go, I can. I was going to say, first I was going to say, could you read this? Now I'm going to say, yeah. I'm going to say you can't. I unfortunately didn't bring a mouse. There's one, oh, hang on, there might be some middle ground.
You can see the cursor.
Yeah, yeah.
Was that
Yep, here we go. Okay. Somewhere around there might be just about good. Right. So here, basically we're just using Go4JS, if you've seen it, is basically an alternative command line toolset for the Go tooling, which will produce JavaScript output rather than native binary. So I just Go4JS build my project. That doesn't work. Because I'm in the wrong place. Right, and that will have produced. There we go. It produced a JavaScript file. At this point, I can now. There we go. Click on before, and you can see that's exactly the same application. Yeah. And you won't be able to hear it very well because it's actually coming out the laptop speakers rather than the external ones, because that's now actually running directly in the browser. But it is exactly the same build with exactly the same application. So that's pretty neat.
Is that hammering your CPU?
Yes. Interesting, we'll talk about that in just a minute. The performance bottlenecks are not what you might expect. The major performance bottleneck that I have right at this moment in time is graphical updates on lower end CPUs. And that's not a JavaScript thing, it's a Chrome thing. So Firefox is well ahead in this respect. I can push sort of 50, 60 hertz animation rates to Firefox, even on a modest CPU and not have it switch much. Chrome is a little worse. Moving into a mid-range client CPU, it's actually fine. There's another coordination problem here as well. There's two threads of execution. One is the audio processing thread, and the other is the user interface updates. In the standalone JavaScript build, those two are sharing a thread execution context, so they're fine. Chrome has an answer to this. It's called Web Audio Worklets, where you can actually put dedicated JavaScript to have your signal processing code done via a real-time priority thread away from the rest of the updates. So, software design. I keep recommending this book. I think if more people read this book, then the world will be a better place. It's a really nice, concise collection of best practice design principles around building good software which is both easily decomposable, layered and testable. And it's a really good read.
What language does it target?
It's very Java centric, but the principles are quite agnostic. So one of the big principles that's taken from this book is what we call the onion architecture. This is about basically isolating your business processes from their external peripheral I/O or interaction dependencies. So we're going in this layered model where the core system and the core of your application business logic, and I'm just going to say audio logic in this case, but it's not really a business application, lies right in the centre. And then you have layers of interaction as you get outwards towards the edge. So at the outermost edge, in this case, we've got platform, which is the interaction with the operating system and external resources. So on this side, the actual physical audio and MIDI signals and so forth. Storage down here, because we're actually going to be able to edit these graphs and store them into files, which you can share and save and all that stuff. Over on the front end side, we've got the display updates and those user interface events. So that's all platform stuff. The actual details of that, the internals of the software doesn't need to know about it in a direct way. One layer in, we've got component user interface, which is the actual sort of front end for these little bits and pieces, like we saw an oscilloscope can display a signal, and on-screen keyboard can display an on-screen keyboard and produce MIDI events. And then right down in the actual core is the actual signal processing stuff itself. And none of that knows anything about the operating system or platform that it's actually being packaged into. It has no outward-facing dependency towards it. How the package is laid out, we've got, there's a nice article on GitHub here about how to lay out the top-level directory structure of a Golang project. So in relation to that architecture, the build part is the actual platform-specific pieces. Package is things that you might actually want to export from your Golang project because they might be useful to other projects. So for example, this user interface sharing thing is in package. And let's just talk a little bit about testing and benchmarking. So I've had very pleasant experiences in terms of how testing setup can work well in a Golang project. If it's done right, it can be blindingly fast. You basically put your tests in the same package directory as your top-level project. You can set your editor up so they run all the time. Every time you hit save, you get a complete test execution suite coverage, and it will pop back into your editor, and your code coverage is working and failing as well. For this project, benchmarking is actually almost as important as testing. Basically because there's multiple platforms. So I want to actually see how well things like that synthesizer graph works on the native one, and I want to see how well it works on the transpiled JavaScript. And I can actually run the same test suite and same benchmarks. So just to demo that. It's actually very basic. It might be the switch spot. Right. So I can just, I've just run that test suite in the Golang target, and now I can run the Go4JS JavaScript target. You're real lucky to all fit on screen. Haven't seen that one before. Fatal error deadlock. It appears that it did actually complete though. The interesting thing I wanted to point out in this one is these bottom two lines, benchmark interpreted and benchmark single sample. Those are two implementations of that graph executor. So back to our on-screen device. Every time I've got new audio, I need to basically walk through this entire graph, execute each processor in a way that the previous inputs are in a ready state for the next node to work, and then produce the output. Single sample mode is with audio sampling and signal recording. You'll typically be recording at CD quality sampling rate, which is 44 kilohertz, 44,000 samples per second. Single sample mode, I go through every step of the graph or every single sample. That's quite inefficient, but there are some cases where, particularly if you have feedback in the graph, that's actually necessary, but it's really slow. So one of the things that those benchmarks tell me, if I look at the difference between interpreted and single sample on the Golang side, so that's about 6 times slower in Golang, and it's about 100 times slower in JavaScript. So some of those, the reason for that is actually there's an indirect call made through a Golang interface to execute that graph in either case, and it turns out that's pretty expensive in JavaScript. But having those micro benchmarks there at the start make it quite easy to do your assessment. And I think we're about on time, so if there are any further questions, I can take them, or I can.
I'm just wondering if you can show any of your test examples you said you enjoyed.
As in terms of the code for the test?
Yeah.
Yeah, sure. So get back to my, yeah, okay, here's one that's right there. So this is a fairly, okay, package MIDI is MIDI protocol, if those are aware of it, is a very old standard for communicating musical event-based information on ancient RS-232 serial links, which has been ported into the modern age and is kind of stood the test of time. MIDI protocol package, in this case, basically defines the sort of nuts and bolts serialization, deserialization of those messages into meaningful data structures. So yeah, we've got basic event types, node ons, node offs, which is those ons and offs, and like pitch bends, which mean notes and those sort of things. So alongside that event module, we just have event underscore test, and for most of those methods, I've got a test case, which pretty simply defines the event as it would have appeared on the actual sort of serial protocol wire, encodes it, and then reads it back and just tests that it's all there. So if I just hit save, there we go. And so it's run the entire suite and told me that I'm actually good on that module. I've got 100% coverage, but it's not my normal target. And it's just a very nice workflow. One of the things that I've actually found building this up, there's a lot of circumstances where things like that sort of graph interpreter, like ordering the instructions to make it work in the correct order, they're very hard to get the algorithm right. And what I often do is I'll write a simple example just by hand of what I expect the output to be, and then I'll use that for a while, and I'll actually turn that into my first test case. And it's quite a nice way to actually start and build up the test suite. Hello.
Hey, have you made any music with it?
That's a good question. And the answer for this new project is nothing I would actually call musical. The older, the older software, the old Luca, right back here. Tracks, which are mostly covers of 70s progressive rock bands that I like. In this software, basically it's a recorded backing sequence, and then there's red boxes where I play my guitar, and the green ones are where the looper plays the guitar back, and I build up a song like that. So I've gotten that as far as playing it at open stage nights and that sort of thing. So that'll be a next target for this software as well. I'll actually port the looping functionality to it, so I can start using it for something real.
So when you execute your test set,
Yep.
and you have your USB keyboard connected,
Yep.
does the system actually play music when you are like executing a test run or doing the
I don't
benchmark?
have any tests which actually generates. They're more sort of benchmarks. So I do have a test around that minimal synthesizer, just to actually benchmark its persistent, its performance. It's not physically connected to any audio output though, so it's just generating the samples and throwing them away.
Okay.
Yeah.
What's something that you found easier than you expected? Like when you went in, you thought, "Oh, this is going to be real hard."
Yeah. Actually, language things around Golang were probably the most pleasant experience that I've had with the Golang platform. I found the type system extremely flexible and easy to work with. That being, say, for example, here we go. So we're talking about earlier about just how we build up the user interface. So I've got these tools here to basically construct an HTML or SVG element. You'll see in this case, this function is just a sporadic function that takes a list of anything. So the first parameter is the name of the element, and the second parameter is very variable. If I pass it pairs of strings, that will be a key value pair for the attributes in the element. If I pass it an event handler, then I register an event handler and so forth. That's a lot of type flexibility for a statically typed language, which actually works really nicely. So that's been a pleasure to work with.
If you had a choice of a different user interface, what if the world was your oyster, what would you pick?
That's interesting. I probably would stick with scalable vector graphics, just because I don't really, for this kind of project, I don't really need the rich sort of CSS layout stuff that you can do with a full HTML interface. I'm reasonably rigid. So it's one of the thoughts that I have, which is this whole WebSocket thing's a bit ambitious. And it's some point in time permitting, what I might actually do is bind more directly to an SVG implementation itself rather than trying to run it in a web browser. That would be an option. That would remove the entire browser dependency and allow it to run as a native app.
Oh, okay. All right. Thanks.